So this is going to be part B of problem number 3 from 2009 Form B of the AB and BC exam. And in part B it says how many values of A, where A is between -4 and 6, is the average rate of change of F on the interval from A to 6 going to equal 0? Give a reason for your answer. Well, if we start with this phrase first, average rate of change, the average rate of change of a function on a certain interval is really just the slope of the secant line connecting the endpoints of that interval together. And so the average rate of change formula on the interval from A to 6 is going to be the difference in y values, which would be f of 6 minus f of A, over the corresponding difference in x values, which would be 6 minus A. We want to know when this average rate of change, when this slope is equal to 0. So if we set this equal to 0, the only time a fraction can ever be equal to 0 is when the top of the fraction is 0. So when is f of 6 minus f of A going to equal 0? Well, if you think about this equation right here, it actually has a nicer form that should be easier for us to think of it in. If I add this f of A to the other side, so if I add f of A to both sides, it says f of 6 equals f of A. And this makes sense. If these two y values in the numerator are equal to 0, when you take the difference of them, your numerator is going to equal 0 if they're the same exact value. So we would need to figure out how many times on the interval from -4 to 6 does f of 6 equal some other function value there. Well, check this out. You know what f of 6 is. You've got the graph of f provided to you. F of 6 is 1. So how many times in between -4 and 6 is the function value on f going to be equal to 1? Well, you can hopefully see that there are two such times. One time is right here, somewhere between -1 and -2 it would seem, and the other time is, well, looks like it's maybe right at 1. We don't know for sure, but we do know that this line, to get from this negative value to this positive y value, it has to cross the value of 1 at some point in between. That's actually this theorem right here, which I have shrunk down a little bit, the intermediate value theorem. There's no way that I can get from this y value, negative whatever, to this y value, positive 2, with a continuous graph, which this line segment obviously is, unless I cross every y value between these two y values at least once at some point in between. Same thing can be said over here. In order to get from this y value at 2 to this y value at 0, I have to cross the y value of 1 at some point in between those 2 points on the graph, at least once in between. So how many times do we have this situation being true? Well, it's going to happen twice. We don't know exactly where it happens, but the reason why it happens is because of the intermediate value theorem.